Have you ever gone to the beach, swallowed a mouthful of seawater by accident, and instantly regretted it? It's bitter. It's strong. And it raises a simple question most of us never really think about. Why is ocean water salty? After all, rain isn't salty. Rivers aren't salty. Lakes usually aren't salty. So why are the oceans different? Today, we're going to break this down step by step. No heavy chemistry lectures. No confusing jargon. Just a clear explanation of where that salt comes from, why it stays in the ocean, and why the ocean didn't start salty but slowly became that way over millions of years. By the end of this video, you'll understand not only why the ocean is salty, but also why it matters. Let's start with something basic. When we say ocean water is salty, we're really saying it contains dissolved salts, mainly sodium chloride, which is the same salt you use on food. In fact, about 85% of the salt in seawater is sodium chloride. On average, ocean water has a salinity of about 35 parts per thousand. That means for every liter of seawater, roughly 35 grams are dissolved salts. That's why you can taste it instantly. But here's the key question. Where did all that salt come from? The answer starts on land, not in the ocean. Salt doesn't magically appear in the ocean. It begins with rocks on land. Rainwater isn't just plain water. When rain falls through the atmosphere, it absorbs carbon dioxide, forming a weak carbonic acid. It's mild, but over time, it's powerful. When this slightly acidic rain hits rocks, it causes chemical weathering. That weathering breaks rocks apart and releases tiny charged particles called ions, including sodium, calcium, potassium, and magnesium. These ions dissolve into the rainwater. Now here's the important part. That rainwater doesn't just sit there. It flows into streams, then rivers, and eventually into the ocean. So rivers act like delivery systems, carrying dissolved minerals from land to sea. And they've been doing this non-stop for hundreds of millions of years. At this point, you might be thinking, if rivers carry salt, why don't rivers taste salty? Good question. Rivers do contain dissolved salts. Just not very much. The reason is movement and replacement. River water is constantly moving. Fresh rainwater keeps diluting it. And the water doesn't stay in the river long before reaching the ocean. Oceans, on the other hand, are different. They act like giant collection basins. Salt flows in, but it doesn't flow out. Now we get to one of the most important reasons the ocean is salty. Evaporation. When the sun heats ocean water, the water evaporates into the air as vapor. But salt doesn't evaporate. It stays behind. So every time ocean water evaporates, the water leaves, but the salt remains. Then that evaporated water eventually falls back to earth as fresh rain, which flows over land again, picks up more minerals, and returns to the ocean. This creates a long-term cycle. Rivers bring salt to the ocean. Evaporation removes only water. Salt accumulates. Over millions of years, this process has concentrated salt in the oceans. That's why the ocean keeps getting salty while rain stays fresh. Rocks on land aren't the only source of salt. The ocean floor itself adds more. Deep beneath the ocean, seawater seeps into cracks in the Earth's crust. It gets heated by magma and reacts with minerals underground. Then that hot, mineral-rich water shoots back out through hydrothermal vents. These vents release dissolved metals and salts directly into the ocean. So the ocean is getting salt from both above and below. Here's something surprising. Scientists believe the early oceans were much less salty than they are today. When Earth first formed, there was no rain, no rivers, and no weathering as we know it. As the planet cooled and water collected on the surface, the oceans slowly formed. Salt built up gradually as rain, rivers, and geological activity continued over time. This means the ocean didn't suddenly become salty. It took hundreds of millions of years. And even today, the salt level changes very slowly. If salt keeps flowing into the ocean, why isn't it getting saltier every year? Because salt also leaves the ocean, just more slowly. Some salt gets locked away in sedimentary rocks. A salt deposits formed when seawater evaporates. A sea spray that lands on shore. A chemical reactions that trap salt in the seafloor. So there's a rough balance between salt entering and salt leaving. That's why ocean salinity stays relatively stable over long periods. Ocean salinity isn't just trivia. It's critical for life. Salt effects, water density, ocean currents, climate patterns, how marine animals survive. Fish, coral, and plankton are adapted to very specific salt levels. Even small changes in salinity can disrupt ecosystems. And those ocean currents driven partly by salinity help regulate Earth's climate by moving heat around the planet. So the salt in the ocean plays a role in weather, climate, and life itself. So, why is ocean water salty? Because rain breaks down rocks. Rivers carry dissolved minerals to the sea. Evaporation removes water but leaves salt behind. And this process has been happening for millions of years. The ocean didn't start salty. It became salty over time. And that salt helps shape our planet in ways most of us never think about. Next time you're at the beach and taste the seawater, you're tasting the result of Earth's geology, weather, and history, all mixed together.